Hello, ladies and gentlemen. Today we are going to start a new unit about special functions. Taking a look at different types of functions that can occur. And before we can do that, before we look at absolute value, piecewise, and so on, we need to build some vocabulary around two very special things that you've already heard of this year, but that are going to look a little bit different now as we progress forward. So that idea is domain and range. So today you're going to need your notes as well as your listening ears. So make sure that you're listening to your audio here because some things you're going to write and some things you're just going to watch and listen. So let's remember about domain and range that we've already done this year, understanding that domain and range are just the x and the y values. And we would make a list of those. So in this example, all the x values, we would make a list in the little brackets there, least to greatest. We talked about all of this before. The range, we can do the same thing with those y values. But now we're going to take a look at domain and range from a graph. So how do you interpret or figure out what the domain and range is from a graph when it's not just a set of points? So for this, I'd like you to write this part down because sometimes it's not going to be possible for us to list all the x values and the y values because the graph is what we call continuous or made up of an infinite number of points. It goes on and on forever. So when that is the case, when we can't make a list, we instead list an interval of values. So we're going to use an interval to describe where the domain and range lie, okay? So an interval means that we're not going to just make a list of numbers, but we're going to describe where the numbers occur. So we look at a graph and we're going to read what it says in terms of the x and y values. And for domain, we're going to read left to right because that's where the x-axis goes, left to right. And for range, we're going to read bottom to top because the y-axis goes up and down. So we're going to read domain and range from a graph, and you're going to see next time I see you a little activity to help us do this. But I just want to make sure that we get the notation down first so that that is not the stumbling block, okay? So domain and range. First one I want you to watch. We're going to write the domain and range using interval notation. So there's two different types of notation you can use to describe domain and range. One is set notation and one is interval notation. Interval notation is more often applied in our school in college algebra, pre-calculus. You're going to see that a little bit more, and it's a little bit more complex to read. So I want to be sure that you understand this notation, and we're going to write this using interval notation then so that you can get used to this way. We've seen it before. So domain and range. Domain is the x values. So for this graph, it is not continuous. It does not go on and on forever, but it is made up of a lot of points. There are points at the end, and there are also these lattice points here along the way, but let's not forget about all the little points that would be in between them as well. So there are an infinite amount of points here that we could sit and draw and write about with all those little decimal values and all those little fraction values. So instead of making a list, we instead will describe where the x values lie. So if I were to read left to right, this is my negative infinity on my x-axis. This is my positive infinity on my x-axis. It looks like the very first x value I start to have occurs right here because right above it is that point. Okay, that's the very first x value I would have. So the very first x value would be -4. The very last x value for this blue graph occurs right here, right underneath this. That would be 2. So I would describe my domain as going from -4 until 2. Now, we used to write this as x is less than or equal to 2, greater than or equal to -4. This is set notation. There's some more notation that goes in front of it, but this is describing an interval. But in interval notation, we throw away the x and the greater than less than signs. Instead, we say my domain is going from -4 to 2, and we use little brackets to say including -4 and including 2. Okay, that bracket there means that 2 is considered part of that domain. Now let's look at the range. The range is the y value. So now I'm going to read my y-axis. That's the one that goes up and down. Starting at the bottom, the very last y value right here is the y value for that part of the graph. That is -2. And then if I go up, 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 so I'm even with the very top of the graph, that would be 1, 2, 3, 4. That would be 4. So my y values go from -2 until 4. And again, the brackets mean that they stop and start at those exact numbers. So that's what interval notation looks like. Again, it doesn't have greater thans, less thans, although it means the same thing. It's just a different way to write them. So this one I'd like you to get in your notes. We are going to write the domain and range again using interval notation. So same idea, domain is the x values and range is the y's. So I'm going to start on the x-axis now, lining up with that blue dot here. This is the x value that would correspond with this blue dot. So this one is over -1, -2, -3, -4, -5, -6, -7. And then this one over here is where the graph stops at 1, 2, 3, 4, 5. So my domain would go from -7 until 5. Now, the bracket, remember, means it includes -7. What do you suppose an open dot at that location means? It means it doesn't actually include the 5. It stops right before 5, like 4.9999999. So we'll just mark the 5 and make an open dot. When that happens, when we write our interval notation, we put a parenthesis right there, okay? It doesn't include 5, but it goes right up till it, okay? So let's do the y values. Now the lowest y value, the lowest part of the graph occurs right here across from this spot. That would be -3. The highest y value occurs right here. That would be 1. So my range goes from -3 until 1. And now remember, -3, that y value down there, if I look across, yep, that was closed. But up at 1 here, this point 5, 1, that was open, so I'm going to block that off with a parenthesis. So sometimes we use the close of the bracket and sometimes we use the parentheses whether or not the interval is open or closed. Now, last one in your notes, you don't need to write down, actually. That was the last one in your notes. Just watch this one. This one's going to include an infinity sign, okay? So domain and range one more time. X, Y. So the domain would be the leftmost x-axis mark here. So this is the very left part of the graph. Looks like it starts at 0 and continues on for, oh, arrow, for forever. So that is continuing on forever in the positive infinity direction. We would say it includes 0 because it actually includes 0. There's no open dot there. And when you go to infinity, infinity is not really a number, so we usually show that one with a parenthesis behind it always, okay? Then range is the y values. The lowest y value I have is also at 0. And I'm going to bracket that one. The highest y value we would have, if this thing keeps going on forever and ever and ever and ever and ever and ever and ever and ever, that y value is just going to keep increasing. So we would say that one also goes to positive infinity. So describing domain and range from a graph means that we're looking at those x and y values and describing that interval. And this is new interval notation, but we've introduced it earlier this year, so it sort of looks familiar, hopefully. I want to thank you for writing that one example in your notes and that little bit of vocab, and then I'll see you later.